Hey guys, welcome to your lesson on ionic bonding. At this point, you should have reviewed your ion notes, which are on page 40 of your interactive notebook, and also gone over your periodic trends lesson. So if you've done those two things, you are good to move on in this ionic bonding lesson. So let's get started. These notes, if you're handwriting them or if you printed out your guided notes, they will all go on page 42 in your interactive notebook. Okay, so let's talk about the requirements for chemical bonding. What even happens when we're talking about bonding? So we know that elements exist in nature either by themselves or they can exist in compounds, so things like sodium chloride, which is NaCl. You guys have seen those so far, but we don't really know how they come together and how they interact with one another. So that's what we're talking about today when we talk about bonding. So there are some requirements for this. Number one, 2 or more atoms are able to bond. Everything but the noble gases. Okay, so the noble gases are stable. They've got a full outer shell. Their valence electrons, they have 8 of them. It's full. They're happy. They're not going to bond because they're not going to be looking for any other electrons in their valence shell or in their outermost valence shell because they're already full. They're happy. Charged atoms, they can be positive or negative. Remember, we saw that with ions. You can lose electrons or you can gain electrons. You have to have valence electrons. So in order to bond with another element, you have to have valence electrons to be shared or given away or taken. And then your atom is always seeking to attain stability. Remember, atoms are stable when they reach those 8 valence electrons in their outermost shell. Okay, so keeping those 4 things in mind, we got to talk about 2 different types of bonds. Okay, the first is the ionic bond, and the second is the covalent bond. Today, we are only focusing on ionic bonds. Okay, so everything that we talk about today will be in reference to ionic bonding. So what is an ionic bond? An ionic bond is the transfer of electrons between a metal and a non-metal. Okay, so stop and let that sink into your brain for a minute. Okay, ionic bonds occur between metals and non-metals. So think about where your metals are in your periodic table and your non-metals. So our metals are to the left, our non-metals are to the right. Ionic bonds happen between the 2 of them. Okay, so remember, metals tend to lose their electrons. They like to give them away and become positive. So they're cations typically. And then our nonmetals like to gain electrons and become anions. Remember, cations are positive, cats have pos, and then our anions are negative because we are gaining a negatively charged electron. So just keep in mind, opposites attract. So positive and negative ions are going to be drawn together. The charges in an ionic bond must combine to equal 0. Okay, so your ions are charged. Okay, they could have a 1 minus, a 1 plus, a 2 minus, a 2 plus charge. But when they come together in an ionic bond, the charges must always combine to equal 0. So your ionic compound will always be neutral. Okay, so let's look at an example. So table salt, what we use for our food, is sodium chloride. Okay, so we've got sodium and chlorine coming together. Sodium is a metal, right? So it's going to lose an electron to become a sodium cation. Chlorine is a nonmetal, so it's going to gain or take on an electron to become a chlorine anion. All right, so if we bring them together, so here we're going to look at their Lewis dot structures. Right, so remember, we grab their valence electrons from which group they're in the periodic table. So sodium's in group 1, chlorine is in group 17 or 7A. So sodium has 1 valence electron, chlorine has 7. Okay, so what's going to happen here is because sodium is our metal, he's going to donate his electron to chlorine so that chlorine is happy and then sodium is happy. Because remember, all elements want to be stable. They want to get to their noble gas configuration. So this little electron here with our sodium is going to be donated to our chlorine and we're going to get an ionic bond. An ionic bond is a transfer of electrons, okay? So sodium's going to lose an electron, chlorine's going to gain an electron, okay? So we've got this transfer going on. And so what we wind up with is sodium chloride, right? So we've got one atom of sodium, one atom of chlorine, and it's going to make an overall neutral compound because a positive one on the sodium and a negative one on the chlorine is going to give us an overall neutral compound, okay? So if we add our dots on our Lewis dot here, sodium, he has transferred his valence electron, and chlorine now has a full outermost shell. They are both happy. Okay, so what if the charges aren't the same? And by not the same, I mean sodium had a positive one, chlorine had a negative one, but what if you've got differing charges? So what if one is a positive 2 and one is just a -1? What do we do with that? Okay, because that's going to be a little bit more challenging. So let's take an example. Let's look at water. Water is made of hydrogen and oxygen. I'm sure you guys already know that the formula for hydrogen is H2O. But if we look at where they are on the table, okay, so hydrogen is on the left-hand side. It's going to tend to donate an electron, all right, 1 electron. And then oxygen, remember, is in group 16 or 6A. So to get to 8, they're going to take on, oxygen typically takes on 2 electrons, okay? So remember, you really do need to go back and review your ion notes if you're confused about this. Okay, so hydrogen's on the left hand with +1, right? It's going to donate 1 electron. And then oxygen is going to take on 2 electrons, okay? Because it needs 2 to be happy to have 8 electrons in its outermost shell, right? So these are not the same. They're not balanced because hydrogen is a +1, oxygen is a -2 charge, right? So how do we balance them? We have to add another hydrogen, okay? Because 2 hydrogen that are both donating an electron would be 2+, okay? So if we've got 2 hydrogens then that are going to form an ionic bond with oxygen, what we'll get is H2O. And remember, ionic compounds, they have to be neutral, so there is your neutrality because these 2 that are losing their electrons, donating them to oxygen so that he can get his outermost valence shell full, right? So these 2, 2+, 2-, add them all together, you get an overall neutral compound. So an easy way to do this is called the crisscross method. So this is the method for actually bonding ions. And there are some steps we're going to follow. Okay, the example we're going to use is water. And here we go. So step 1, you're going to write the symbol for each element. Okay, so water we know has H and O in it. Okay, so water is composed of H and O, hydrogen atoms and oxygen atoms. Step 2, we're going to write the charge for each. So hydrogen typically is going to donate 1, so he's going to be a +1, and oxygen will take on 2 electrons to fill its valence shell. So we've got a +1 and a -2, okay? Now step 3, we're going to crisscross the charge to the opposite element as a subscript, okay? So what do we mean by that? When we say crisscross, what you're going to do is you're going to take the charge on your element and you're going to cross it to the opposite element, okay? So we're going to take this +1 here and we're going to cross it across to this oxygen. And we're going to take this 2- that's over here and we're going to cross it to the hydrogen. Right, so this 1+ is going to go down to our oxygen, and then our 2- is going to go to our hydrogen. You just cross the superscripts to be the subscript of the opposite atom, okay? And so what we wind up with is H2O1, okay? But we don't say O1 because if there's just 1, we're going to drop it. So you're going to drop the charge, but you're going to keep the number. So we're not going to say H2- O1+, we're just going to drop that denotation of the charge and we're going to say it's H2O. okay? And no, we don't have to write the 1, but if it helps you, you can put it there. So that's ionic bonding, and that's your crisscross method. I'm going to post up either a review video that shows you how to do this a little bit more in depth, or maybe some examples that I go through myself. Watch that video. Once you guys feel comfortable, go ahead and complete your ionic bonding assignment for today. So today's Tuesday, the 31st, which means that your ionic bonding assignment will be due Wednesday night at 11:59 p.m. for full credit. If you guys have any questions, let me know. And if not, good luck.